Hi everyone, this is Professor Sebastian. Welcome back to our statistics class notes. We are in the middle of page 102, and I split up the last video between this one because I wanted to make sure I got this entire example, which runs on to the next page in that short video. Okay, so we're starting here with example 133, and I'm going to demonstrate to you using the central limit theorem for sample proportions. So according to the Washington Post, in 2016, it was estimated that 36% of Americans own guns. Suppose a random sample of 500 Americans is taken. Okay, so kind of putting all the information we have together in Chapter 7 so far, let's run through this. Who is the population? First of all, that's all Americans, right? I took a random sample of 500 Americans, so that's trying to represent all Americans. The sample is the 500 Americans that we sampled, of course. Now that value 36%, is that a parameter or a statistic? And what symbol do we use to represent it? So 36% was given to us from like past information from the Washington Post, where they were telling us that they estimated 36% of Americans own guns. So we're to assume that's the population proportion P, which would be 0.36 or 36% of all Americans own guns. So that's from a population, that's a parameter. P equals 0.36 or 36%. Is the value 500 a parameter or a statistic, and what symbol do we use to represent it? Well, the 500 is not a parameter or a statistic, it's just the sample size. If you were going to call it anything, I guess a statistic, but I don't put it in either category. It's the sample size. How big of a sample are we taking? N is equal to 500. Is the sample random and independent? We're going to mostly always assume it is. Okay, we were told we were given a random sample, so whether it's independent or not, we just have to assume that it is the case at this point. Is the sample large enough? So remember, we have to have at least 10 successes and 10 failures. Successes doesn't mean positive or connotation. Failures doesn't mean negative connotation, but we're going to think of owning a gun as a success in this case. So is the sample size large enough? Well, 500, we should expect 36%. So 500 times 0.36. In a sample, we should get around 180 of those 500 people to say, yes, I own a gun. And that's certainly more than 10. The number of people that say they would not own a gun, or the no's, would be n times 1 minus p that we should expect. So 500 times 1 minus 0.36, which would be 0.64, or 64% of the sample, which comes out to be 320, is certainly also more than 10. So the sample size is large enough as both the successes and the failures are more than 10 that we would expect. Is it reasonable to assume that there are is the population at least 10 times bigger than the sample size? So are there at least 10 times 500 or 5,000 gun owners in the population? We should say yes, certainly. In the population of the United States, or all Americans, absolutely. So the conditions for the central limit theorem are met. Now, what does this mean? This means that based on the central limit theorem, and we met those three conditions, we can assume that our sampling distribution is approximately normal, that the mean of that sampling distribution of all the samples proportions is right here in the middle at 0.36, which is the true population proportion, and the standard deviation of our sampling distribution, which we call the standard error, is given by p times 1 minus p divided by n. Take the square root. So that comes out to be 0.0215 after you do the calculation. So we have a normal distribution with a mean of 0.36, the true population proportion, and a standard deviation of the standard error, which is 0.0215. In the next example, in this example, I'm sorry, I then ask in the last question, what is the approximate probability that the proportion of gun owners in our sample will be more than 40%? So that is asking what's the probability that X is greater than 0.4. That's 0.0314. So how do I do that? I go to my standard normal calculator in StatCrunch. I put in a mean of 0.36. I put in a standard deviation of 0.0215. And I then say I want the probability for X to be greater than 0.4. I hit compute and I get 0.0314.